Okay. All right, so looking at our last or our second to last section, we're looking at parabolas today. Remember, we're looking at conic sections, which is basically a shape, a 2D shape that's made when you have basically an intersection with a cone. So I know you've talked about parabolas before in Algebra 1, Algebra 2, even this year we did stuff with parabolas. It's going to be a little bit different. We're going to have a slightly different formula, but you'll see it still kind of holds the same kind of general truth. It essentially is going to be y equals x squared, but we're going to have some extra stuff because a lot of times when you do conic sections, you look at different parts like with the focus and this directrix. If you look on the right side here, your axis of symmetry is still, if you remember what that is from before, it's basically just the line that would cut it down the middle. It would fold evenly. A focus is kind of like what we saw with the ellipse. It's an equal distance from a point on your parabola and a line that we call directrix. We're not going to do a ton with this, to be honest, in this class, but like I said, if you do study conic sections in a future class, you might go into more details. My big focus is really just to get our graph. So really what's important for us is really just finding our vertex, axis of symmetry. Those are really going to be our key things. But I guess we'll draw these other things just to kind of see how they work. But one thing just to remember is that if you look at this diagram, the distance, the first distance, no, it's not good. Oh gosh, one of those days, isn't it? It's good. Parabolas after, okay. Alrighty, my bad. But remember that the first distance is always going to equal that second distance in this diagram. And that's just what a definition of a parabola is in terms of a conic section. But to be honest with you, it's for what we're doing, it's probably not going to be that important. Types of parabolas, well, you're either going to have a vertical or a horizontal. So a vertical is kind of like the standard parabola, probably what you think of, while a horizontal is going to be basically like a sideways U. We'll see there's two kind of formulas to get these, but some vocabulary below. The focus always lies inside the parabola, so that focus point. The directrix, sorry, is a line that always lies outside the parabola. The directrix and axis of symmetry are going to be perpendicular. Oh, what am I writing? Sorry, axis of symmetry. That's really sloppy. Symmetry. And the vertex is always the absolute value of P units away from the focus and directrix, because you can always have a positive distance. So that's why it's the absolute value in case you have a negative P. Looking at these pictures just to try and describe some of these vocabularies quickly. Like I said, for the purpose of this class, and especially like kind of how this year is going with the whole online learning, that my big focus is really for these conic sections just to be able to get a graph of them. But some of these vocab words are probably good to know. Like in this diagram, this would be your axis of symmetry. This line that cuts the parabola down the middle. This dotted line outside your parabola is called the directrix line. This point here inside the parabola is your focus point. And like when we find our p-value, what the p-value basically tells you is, when we're graphing, it's the distance from your vertex to your focus point, and it's also the distance to get your directrix line. So like you go, like, so we're going to be, like when we're graphing today, we're going to be finding a p-value, and basically that's going to help us get our focus point, and that's going to help us get this directrix line. And it's always going to be this dotted line, and you'll see that your axis of symmetry and your directrix are always going to be perpendicular to each other. Because but basically that's going to be kind of when we're graphing, we're going to be finding this p-value, and that's going to help us kind of get our focus point in our graph and also our directrix. Very similar horizontal parabola. I mean, same idea. This line that cuts your parabola down the middle would be your axis of symmetry. So our axis of symmetry is horizontal in a horizontal parabola. I guess one thing I could have labeled earlier, the middle point's your vertex. I have to label that in the original, but this would be your vertex, like that center point. This would be your focus point. And this line is your directrix line. But you're going to see, like, once you get your vertex, to get your parabola, you go p units to get your focus point, and you go negative p units to get your directrix. But basically, you go p units on both sides. If it's horizontal, you're going left and right. If it's vertical, you're going up and down. But we're going to be looking at a lot of examples. So I know probably right now you're like, what the hell are all these terms meaning? But well, basically, that's the idea. But once you get your vertex, you kind of use this p-value to kind of get your other pieces. And then you kind of just sketch it from there. But we'll kind of see how that works. Keep this up. Are you still writing, Nyla?
No, I'm good.
Oh, you're good? Okay. And I also did post a key of the notes as well on Google Classroom. So if you can't read something I'm writing, or you don't feel like watching this video, if you're watching later, it's the key's up there as well. We're going to have a standard form for our equation. So we kind of have two formulas, one for vertical, one for horizontal. So this first one I'm going to put, I'll just put a little v. This is our vertical. This is our horizontal formula, just so you know. So if it's a vertical, you're going to have an x minus h squared equals 4p, stylus is crappy, times the quantity of y minus k. And kind of notice it kind of is like x squared equals kind of a y term on the right side. So it kind of holds true to like the equation you would know of a parabola. Stylus is starting to break. Let's see, hopefully it lasts the year. Our horizontal formula is going to be pretty similar. It would be y minus k squared equals 4p times x minus h. So pretty much they're very similar. I mean, one thing to notice is that the y and the k part always go together. Sorry, this is kind of sloppy. Inside this first one, it's y minus k. But like your x minus h and your y minus k always kind of stay inside the parentheses. But basically, these are just kind of flip-flopped. If you look, like this one has the y minus k part squared. The vertical one has the x minus h part squared. To see if it opens up or down, if it's vertical, you look at your p-value. If your p is a positive number, it opens up. If p is a negative number, it opens down. Same idea kind of with the horizontal. If your p is greater than 0, it opens to the right. If your p is less than 0, it opens to the left. So either you're gonna, like if it's horizontal, you're gonna either have one that opens to the right, oops, or to the left. Am I doing that right on the video? It might be backwards because it's mirrored. I don't know. And then if it's a vertical, you're gonna have it open up or open down. So without further ado, though, we are going to start getting into the graphing. Like I said, this is what you can expect from your assignment this week. But basically, our goal is to get our equation in standard form if it's not already. We're going to find our vertex, and then we need to find our p to figure out first, is it open up or down, and to get our focus and directrix. And then we'll graph. So let's look at a few examples. We have a lot of examples. We'll see if we do them all. I might just focus on the ones that are kind of already in the form. So looking at example 1, first thing you want to kind of think about is looking at your equation. You have x squared equals negative 8y. You want to think about, is your x part squared or is your y part squared? So in this problem, since our x squared part, like our x is the part that's being squared, that means you're going to have a vertical parabola. So that means it's going to open up or down. And we'll find our p-value in a sec to figure out that. But it's vertical because the x part that's squared. For example, like number 2, the y part's the squared part, so that's going to be a horizontal parabola. That's kind of the first thing you want to think of. The next thing you can do is find your vertex. To find your vertex, you look at what's with your x and what's with your y. Like, for example, if you had x minus 2 in parentheses, Damien's gonna go, he'll be back, okay. But you wanna look at what's with your x and what's with your y. Since there's nothing with your x, like it's not x minus 2 in parentheses, there's nothing with it. There's nothing with the y. Our vertex would be 0, 0. So it's kind of like how we found the center of your ellipse and circles. It's kind of like what's inside, like if you have something with your x or with your y, kind of what's inside. But since we don't have anything with either one, like inside parentheses, it's just going to be 0, 0. Your axis of symmetry, it depends if you have a vertical or a horizontal, but it's either going to be a vertical or a horizontal line. Since this is a vertical, our axis of symmetry is going to be a horizontal line. Like if you had, I'll erase this in a sec, but if you had a parabola, like the axis of symmetry is going to be a horizontal line down the middle of it. So it's going to be x equals, and it's always, if it's x, it's just the, it's just the x value of your vertex. So the x value of our vertex is 0. Okay. The next thing we need to do is we need to find our focus and directrix. To get those 2 points, we need to find our p-value. So to solve for our p-value, if you remember the formula we looked at earlier, your p-value is like the coefficient, and it's 4p is your coefficient of like your y part here. Like if you look at this formula, see, like our p-value is this part of our equation, right? So to solve for our p-value in this, if we look in our equation here, our 4p part, like the part, our coefficient of our y part in this, is this -8. So to find our p-value, we're going to take 4p equals -8. And to get our p, we just saw this, so just divide by 4. So our p would be -2. Since our p is negative, that means our parabola is going to open down. So I'm going to have a vertical parabola that opens down. So to graph this, I'm going to see it's not too bad. I mean, and you could do more if you could plot points if you're really trying to get accurate. But for my purpose, I'm not too worried. But you could, like, to see how wide or how thin it's going to open up, you could do different things. But the first thing you do is just plot your vertex. So 0, 0. And then to get your focus point and your directrix point, you're just going to go up, like from this vertex, since it's vertical, you're going to go up to, and you're going to go down to. Oops. You put those dots. Well, so which one's your focus? Which one's your directrix? Well, it kind of, I mean, really just think about is your graph opening up or down? Since we're said it's opening down, our parabola is going to look something like this. So that means this point, I'll do it in yellow. This is your focus point. And I'll do this point in red. This is your directrix point. So your directrix would be a horizontal line that looks like this. And your focus point's that yellow point. So you could just look at your graph, or it's just basically you take your vertex and you go up to, down to. So our focus point, those that yellow point, so that would be 0, -2. Our directrix would be, since it's a line, it would be that horizontal line. It would be y equals 2. So that's kind of the idea with these. It might seem a little bit weird, but once we do a few more examples, like, I mean, you should kind of start to see kind of how these problems are all going to be pretty similar. I think maybe the weird thing might be this p part right now, but basically you just look at the coefficient of that second part of your equation and set it equal to 4p, because that's just based on this formula here. Like the 4p part is just the coefficient of your non-squared variable part. So it might seem a little bit weird, but it's just based on that formula from the first page. So let's look at another one. Oops. So number 2, we have a horizontal parabola. And remember how we knew that's going to be a horizontal is because it's y squared. The y part's up to the power of 2. So what we need to do next is, well, we can find our vertex. Once again, since we don't have anything like with our y, with our x, like if you look at number 3, you have like the -2 with the y, you have the -3 with the y. So number 3, we'll see when our vertex isn't 0, 0. But since there's nothing with the y, nothing with the x, like inside parentheses, you're just going to have a vertex at 0, 0. The next thing we want to do is find our p-value. So remember, 4p is equal to the coefficient of your non-squared variable. So really we'd have 4p equals 6. So if we solve for this, just divide the 4 over, we're going to get p equals 6 over 4, or 3/2, or if you want to put a decimal, it's 1.5. That'll probably be easier to graph if we do a decimal. Since our p-value is positive, since it's horizontal, it's going to open left or right. Positive goes to the right. So this is going to be a horizontal, and it's going to open to the right because our p-value was positive. To get our axis of symmetry, since it's a horizontal, like if you think of a horizontal parabola is going to look like this, the axis of symmetry would be a horizontal line. So you're going to have y equals, and it's always, if it's y equals, you look at the y value of your vertex. Okay, so now we're ready to graph this. So plot your vertex. So 0, 0. Sorry, this is hard on my iPad because my stylus is big. And then you're going to use your p-value. Since it's horizontal, you're going to go left and right. We're going to go to the right 1.5. Yeah, it's going to be hard for me to be exact, but pretend this point I'm drawing is at 1.5, and then you're going to go left 1.5. And since our parabola opens to the right, we go from the center, it would look something like this. So this point, because it's inside our parabola, this yellow point, that's my focus point. This red point would be my directrix, and it's going to be a vertical line because it's always going to be perpendicular to your axis of symmetry. So, and then it might just be easier to look at your graph, but like my focus point would be that yellow point, so that was 1.50. My directrix point, or it's a line, so, and it's vertical, so it's x equals, and that was negative 1.5. Let me rewrite that, that's really sloppy. Oops. So like I said, my focus point was 1.50. Oh no. It's happening again. Okay, go away. Okay, oh, okay, not that bad. And then our directrix would be x equals negative 1.5. All right, let's look at some where our vertex isn't 0, 0. So looking at number 3, the first thing, like I said, I would think about it, do you have a vertical or horizontal? Well, since the y part is up to the second power, the x part's not. That's going to be horizontal like the last problem we just did. To get your vertex, you look what's with your y and what's with your x inside the parentheses. So, and you kind of do the opposite, but be careful. You always got to do the x part first, and then you always have to do the y part for your vertex. So the part with my x would be +3, and then my y part would be +2. You do the opposite sign when you pull it out, but make sure you always do the x part first and always the y part first. It doesn't matter if you have a horizontal or vertical ellipse. So be careful about that. Don't, like, one common mistake students might put is like 2, 3, but always the x part and then the y part. So now we need to solve for our p, our axis of symmetry, I guess we could do actually. Since it's horizontal, remember, you're always going to look at your, what am I doing? It's not a point. Axis of symmetry is a line. Since it's horizontal, that means, like, if you have a horizontal parabola, your line that would be the axis of symmetry would be horizontal. So that's always a y equals. So it'd be y equals and then the y value of your vertex. Or you could even wait to graph and you might be able to see the axis of symmetry easier. But the next thing we're going to do is find our p-value. So remember, this part in front of your second variable, like on the right side, is equal to 4p in that formula. So we have 4p equals -4. So if you solve this, you'll get -1. Since this is negative for our p-value, that means it's going to open to the left. Just using my finger. Okay. So now we're ready to graph. So our vertex is 3, 2. Since our p-value is -1, it doesn't matter that it's negative. You're just going to go left 1, right 1. This is hard because my stylus isn't working. Let me see if I can like really zoom in. So you plot your vertex at 3, 2. You're going to go 1 to the right, 1 to the left. Since we found out earlier it's going to open left, our parabola is going to look something kind of like this. So this yellow point, the one inside, is your focus point. This point on the outside would be your directrix. So that would be like a vertical line. Keep in mind, this directrix isn't actually part of your graph though. Like if you put this equation into Desmos, it's just going to make this black part. This directrix and this focus point are just things that, especially if you do future applications with conic sections, like knowing stuff about the directrix and focus points can let you like solve for different things. But like it's not actually part of our graph. That's why like in most of these problems, I didn't do it on this one though. This directrix line, when you draw it, usually you put a dotted line because it's kind of like an asymptote in a way. Like it's not actually part of your graph. It's useful depending on what you're doing. So using what we just graphed, my focus point would have been 1 to the left of the vertex, so it would have been 2, 2. And my directrix was a vertical line, so that's x equals, and that was at what, 4? Let's see how we're doing. Okay, agree with the key so far. Okay, let's look at another one. And then maybe we'll start looking at some of these that aren't in standard form. Like I said, I don't think you'll probably have any problems like this on your assignment. So once we finish example 4, if you want to just peace out, I mean, you would be fine in terms of our assignment. But I'll do these last few problems if you want to see how they work. If it's not given to you in a nice form, which a lot of times you probably won't be given that all the time. But looking at this first one, first thing, like I said, is look at which variable's squared. So our x part's the part that's being squared. So this is going to be a vertical parabola. To get your vertex, look what's with your x. So that'd be -1. What's with your y? -2, because it's the opposite. It's kind of like when you pull out a center or uh, vertexes of different things we've seen this year, like pulling out your H and your K. So our axis of symmetry, since it's vertical, that would be a horizontal line that would go down the middle. So that would be x equals, and the x value of a vertex is -1. Now we need to find that p-value. So to find your p-value, remember you look at the number in front of your second variable, so that'd be 14. That would be the 4p part of your formula. So divide by 4. 14 divided by 4 is 7/2, or probably be easier to think of it as a decimal, so 3.5. Since it's positive 3.5, that means it's gonna, since it's vertical, it would open up. So now we're ready to start graphing our parabola. So I gotta zoom in because I'm using my finger right now because my stylus isn't really cooperating. Our vertex was what, -1, -2, right? Yeah. So -1, -2, be about there. And then since it's vertical, you're gonna go up and down our p-value, so we're gonna go up 3.5, so that would be at 1.5, and then you're gonna go down 3.5, so that would be at 5.5. Since we said it opens up, our parabola is gonna look something kind of like that. So this, I'll keep doing what I've been doing, sorry. This yellow point, this would be your focus point. This red point would be your directrix line. So your focus is, like I said, that yellow point. So our yellow point was 0, 1.5, right? Yeah, that's what I said, right? And our directrix was that red line, so that would be a horizontal line. So yeah, y equals, and it was, how far did I say it went down? It was -5.5. Okay, so that's really what you need to know if it's given to you in standard form. If it's not in standard form, you need to do a little bit of manipulation to get it in the equation, then it's just like what we've been doing. But I'm pretty sure on your homework, you only will see questions that are already given to you in standard form. So like I said, if you don't want to look at these last few examples, I mean, it won't hurt you in terms of this class. I'm not going to lie to you. But it is, like, honestly pretty good to know. I mean, if you're actually studying conic sections like in next year's class, I mean, you probably won't always be giving them to you in standard form. So these last few examples aren't given to you in standard form, so we're going to have to do a little bit to get it in that form. Some of them we'll have to, I think we'll have to complete the square. So this first one we don't though. But so similar idea though. First thing you want to do when you're looking at this problem, I mean, I guess you could get it in standard form. So remember, standard form is you always have like the x minus h squared equals 4p times y minus k. Basically what's important is you don't want any coefficients with your variable that's being squared. So like if you look at number 5, the problem, like why it's not in standard form, is we have that 1/4 with our part that's being up to the second power. Like we don't, that's no good. That's a problem. So to get rid of that 1/4, we could just multiply both sides by 4. So my standard form would really be x squared equals 4y. So that's good because you can have a coefficient with the variable that's not up to a power. That's just your 4p part. You don't want anything with your variable that's up to the second power. So since our x part's the squared part, this is going to be vertical. To find our p-value, remember this is your 4p part. You would just get that your p is 1. So that means it opens up. Your vertex would just be, since there's nothing with your x, there's nothing with your y, would just be 0, 0. That means your axis of symmetry, since it's It's vertical is going to be a vertical line, so that would be x equals 0. So we're ready to graph. So if you graph this, you would just go to 0, 0, put a point. And since it's vertical, here, let me zoom in a little. Since it's vertical, you're going to go up and down our p-value, which was 1. And we said our parabola is going to open up. So it looks something like that. So this inside point, this is your focus. This outside point is your directrix. So our focus point would be 0, 1. Sorry, that's the yellow one. Our directrix would be y equals -1. I guess one thing to kind of notice too is that your axis of symmetry and directrix will always be opposite. So if you have x equals something for your axis of symmetry, your directrix is going to be y equals something, because they have to be perpendicular. So if that kind of helps keep, as long as you get one of those right, just know the other one's going to be the other variable. If you're ever getting confused which one's x, which is y, because sometimes even myself, I'm sure you can see in this video, I'm always kind of having to think a little bit about whether it's x equals or y equals. But one tip is that it's always going to be the opposite of the axis of symmetry. So if you look at all these problems we've done, like our axis was x equals, our directrix is y equals. Our axis is y equals, our directrix is x equals, because they have to be perpendicular. So that's one thing that could maybe help you keep it straight. All right, let's look at this one. Similar kind of problem. We got a bunch of junk on the side with our variable up to the second power. So we got two problems. That -3 is an issue, and that -1/10 is an issue. So the first thing I would do is add the 3 over. And then to get rid of that -1/10, we could just multiply by -10. You got to multiply each piece by that. So we would get y plus 2 squared equals -10x minus 30. Is that right? Can you have something added or subtracted? Oh yeah, we can factor it down. Okay, perfect. Oh crap, I'm running out of space. I'm gonna move this up to here. So one other problem is, remember, we want the right side to be in the form of like 4p times, in this case, x minus h. So you can factor out a -10 on that right side. So it would be parentheses x plus 3. So our vertex, if we look, it would be -2, -3. Since our y part's being squared, this is going to be horizontal. Kind of running out of space to find my p. I'm going to do my p work down here, and then I'll just erase it when we do the next problem. To get your p-value, remember that's this -10. That's your 4p part. So if you divide that like in your like -10 divided by 4, that's going to be -2.5, right? Yeah, -2.5. So since our p is negative, this would open. Since it's horizontal, it's going to open left. So now we're ready to graph. We've got our vertex and we've got our p-value. So our vertex is -2, -3. Since it's horizontal, we're going to go left and right, and we set our p-value is 2.5. So you'd have 1 over 0.5, and you'd have 1 over left 4.5. And we said it opens left. So this would be your focus point. This would be your directrix. So just to kind of fill in our information, well, first off, in our axis of symmetry would be, since it's horizontal, it would be horizontal line. So it'd be y equals -3. Our focus is that yellow point, so what would that be? That would have been 2.5 left of the vertex. That would have been -4.5, -3. And then the directrix was 2.5 to the right, so, and it's a vertical line, so it's x equals 0.5. Oh no, oh no. What have I done? It's like anytime I touch the sidebar, it like jumps to that page. It's super annoying. I don't know if there's probably a way to like turn it off, but I'm not smart. So you just have to live with me screwing up every video for the rest of the year. Jeez.
Why don't you just click the page you needed to go back to?
I don't remember what page we're on. Okay. But that is our answer for number 6. But basically, if it's not in standard form, you want to get into that form. And to be in standard form, you want the part that's being squared by itself. I mean, you can have something inside the parentheses, like we had the y plus 2. That's okay. You just don't want any coefficients or anything added or subtracted. And you want to get it in a form on the right side of 4p times y minus or y plus whatever. So you don't want a coefficient with the y part either. So you want to factor it out as the GCF. So that's kind of your goal with this. So this one was kind of tricky. I think this one was kind of tricky, but hopefully seeing it worked out, it kind of helps. Like I said, you probably won't see any like these on your assignment, but not bad to see. Oops, I don't know what I just did. It said save image, so I saved something. Awesome. Let's look at one. These last two, we're gonna have to complete the square, I believe. So notice we have a y squared part. So it's going to be a horizontal ellipse. So basically, and we have a minus 2y. So basically my goal is get your variable with the square, all the y parts on one side, get all your x's to the other side. So like in this problem, I would move that 16x to the other side by add-in. So I'd have 16x minus 33. And I want to get rid of, like, I mean, I need to get this in the form of y either plus or minus something up to the second power. So to do that, I can complete the square. I wish I had more space, or if I just didn't write ginormous. I'm going to do it over here. Remember, to complete the square, you do b over 2, so that would be -2 over 2 squared. So that would be 1. So if you factor this would turn into y minus 1 squared. But remember, when I complete my square, if I added this plus 1, I have to add it to the other side here. So my right side would really be 16x minus 34, which we're going to see is really nice, because if not, it wasn't going to factor out nicely. So the left side's good, but the right side, I want to get rid of this coefficient with my x by like factoring it out, like pulling out a GCF. So I could rewrite this. I could pull out a 16, so this would just be x minus 2. And like, I mean, I guess it's possible for this to not work out nicely, but like, I mean, for these problems, they should. I mean, because if not, your vertex is going to be like a decimal, and it would just be hard to kind of graph by hand. But just FYI, like like for any problem, like you're going to see like in this class, or I would even assume in most classes, like you should be able to pull out a GCF nicely of that right side. I mean, if not, you'd have decimals, which wouldn't be that bad, but it definitely wouldn't be like easy to graph super accurately. All right, so since our y part is the squared part, this would be horizontal. We got to find our p-values. Remember, you look at that coefficient, the 16, we're going to do 4p equals 16. So if you divide that over, you would just get p is 4. So since that's positive, this is going to open to the right. Our vertex would just be 1, 2. Like if you look at what we had here. The one, oh wait, did I screw that up? Hope I haven't messed this up in another problem. Remember, you always got to do the x part first, then the y part. So this would be 2, 1. Crap, I wonder if I screwed up. I haven't been thinking about that. Did I screw up any of these other ones? Oh gosh, I did the last one. Let me check. That one's fine. That one's fine. That one's fine. Gosh dang it. Number 6, I made an oopsie. My vertex, so it screwed up every other part. My vertex, you got to do the x part first and then the y part. I erased it, but it's backwards because it's the y plus 2. That's my y value, the -2 part. So I goofed up this one. Gosh dang it.
Just use your thing to move it.
What do you mean?
You know the little like pencil looking thing by the eraser up the top? You could like circle the graph and just move it over.
This thing?
Yeah.
I can.
Like if you circle,
Oh,
like you could just move it. Oh, well,
like this?
get in there.
Oh, so my vertex should have been -3, -2, right? Should have looked like this. So I guess this would have been, I didn't know you could do that. So this should have been -2. The focus would have been negative uh, -5.5. -2. And then the directrix would have just been x equals -0.5. So sorry, it kind of just threw everything off because I had the wrong vertex. That's what I screwed up. But all right, back to this one. That's the only problem I messed up, by the way. And the reason I screwed it up, like I said, like why my vertex is 2, 1 is because my x part's the 2, my y part's the 1. That's one thing, like I even mentioned, it's an easy thing to screw up, and I did it today. But it happens. Like I know we won't be taking like a test, but if I was giving you like a chapter test over this, that's one of the common mistakes I usually saw, at least last year. But now that we have our vertex, we know it's horizontal, we know it's moving right, we know our p-value is 4, we can graph this. So our vertex, we say it was 2, 1, right? Yep, 2, 1 and +4. Okay, so 2, 1's our vertex. We're gonna go, since it's horizontal, we're gonna go left 4. We're gonna go right 4. Make sure I counted right. Yep. And we said it's right. So it looks something sort of like that. So this is my focus point. This is my directrix. Oops. So if we write down our ants, like our info, this one would be y equals 1. Our focus point, if you look at your graph or just count, was 6, 1, and our directrix would be x equals -2. Okay, let's look at one more really quick because I feel this video is already pretty long. So I'm sure no one's going to watch this far. Do I want to do this last one? Not really, but I'll do it. So get the x part. Since that's your squared part, we're going to put that on the left side. I'm going to move everything else over to the right. We got to complete the square. So that would be like half of 10 squared. That would be 5 squared. So add 25. So I have to do that to both sides. So if I do that, I'm going to have x plus 5 squared on the left side. On my right side, I'm going to have negative 4y plus 24. And then the last thing you do, you can factor that right side. You can factor out a negative 4. So that would be 24 divided by 4 is, it's negative 4. So it would be minus 6. That left side stays the same. So since our x part squared, it's vertical. To get our p-value, we take that coefficient. So in this problem, it's negative 4. So if you set that, you're going to get p as negative 1. So since it's negative, it opens down. So our vertex, if you look, it's the x part would be negative 5. Our y part would be 6. So now we're ready to graph. So it's negative 5, 6. Negative 5, up 6. And we said our p-value was negative 1, so we're going to go up 1, down 1. Since it's negative, we said it's going to open down. So this would be your focus point. This would be your directrix. So our answer would be, well, our axis of symmetry is going to be x equals negative 5. Our focus point would be, if you look, it's negative 5, 5. Our directrix, since it's a horizontal line, it's going to be y equals, and it was up 7. Okay, so that's how you graph parabolas. Most of it's like on your homework assignment, which I'm going to post tomorrow, you're going to see all the problems with hyperbolas. They're going to be given to you in standard form, so you shouldn't have to do what we had to do in problems 5 to 8. But as you can see from my mistake, one thing to be very careful about is just make sure you write your vertex. Make sure you always put the x part first and then the y part. So like number 3, your vertex would be 3, 2. So that's like a very easy mistake to make. But that's it for today. I'm sorry this video was pretty long. Let me stop.